You know, there are a lot of laws all around us, and we have to obey them. But two of my favorite laws actually involve trigonometry, and I want to share them with you because they are really useful and they are really neat. The first one is called the law of sines, and it basically tells us that no matter what triangle you think of, doesn't have to be a right triangle. Any triangle at all will obey certain properties involving the trigonometric function sine. So here it is. For any triangle ABC, doesn't have to be a right triangle, could be anything at all. If we have the sides, length is always little a, little b, little c, corresponding, of course, to the opposite of the angle. So capital A's as an angle here, and the side opposite is little a. This is very important now. Capital B angle is here, and the side opposite is denoted by little b, and C, side opposite, is denoted by little c. Then, the law of sine says that these three ratios are equal. Sine of A divided by A, the length of the opposite side, is going to equal the sine of the angle B divided by the length of its opposite side, and that in turn will equal the sine of the angle C divided by the length of its opposite side. It's absolutely amazing, and it's true, and it actually really will come in handy as we try to think about various issues involving any kind of triangle, not just a right one. Let's take a look at an example where you can see this happening live, up close and in person. So what I want to do is I want us to take a look at this triangle. You can see it's not a right triangle. This is 94 degrees, 25 degrees. This length is 11. I want us to find this length right here, the length PQ, which I'll call little r. Well, how am I going to do that? Well, it turns out that here I'm not going to be able to use sort of any trig function like before because this is not a right triangle, so I can't just do opposite over hypotenuse or something like that. There's no hypotenuse. There's no right angle. Also, Pythagorean theorem is not going to help us because, again, there's no right angle. We have no right angle stuff, but we've got the law of sines, which says doesn't make a difference what kind of triangle, you've got these ratios all equaling. So here we go. Since I know 11 is the length of the side opposite the angle 94, I can see that sine of 94 divided by 11 will equal the sine of 25 divided by the length r. And that gives me a connection that links the unknown to all the knowns. And so I see sine of 94 degrees divided by 11, sine of this angle divided by the length of the opposite side, is going to be equal to the similar thing here, sine of this angle divided by the length of its opposite side, which we don't know, and that's r. So I can use the cross product to actually solve this, and if I use the cross product, I'd see that r times sine of 94 degrees will equal 11 times the sine of 25 degrees. And if I divide both sides by 24, a sine of 94, then I see that r is equal to 11 times the sine of 25 degrees divided by the sine of 94 degrees. And now we can actually compute this on a calculator to estimate it. Let's just estimate it to the nearest tenth. And normally I'd say, oh, just do it, and I would just sort of tell you the answer. But actually, I want to do this with you because, well, I just want to do it with you, and I'll show you why. So let's take 11, and we're going to multiply it by the sine of 25. Now, it seems like we want to push divided by now. But let me just tell you that since we want to do something else, we actually have to close the parentheses on the sign. So I hit the little close parentheses button there, and you can see it happening right there close up. And then I push the divided by, and then I hit the sine of 94. So you have to remember to close the parentheses if you're going to do more operations after a sign. And then I see that we get 4.6601 da-da-da-da-da. So if I just round to the nearest tenth, I see 4.7. So this length r turns out to equal 4.7. And we got it via the law of sines. Really cool, because this triangle was not a right triangle. I think it's amazing. You can start looking at all triangles and extracting information even when they're not quite right. I guess they must be wrong. Okay, anyway, here's a triangle. Let's see if we can make some sense out of this. So I know that this is 9, I know this is 8 in length, and I know that this angle is 62 degrees, and I want to find the angle F. That's my mission, is to find angle F. we'll round to the nearest degree. But let's find angle F. Well, again, I can use the law of sines because I see a measure of an angle and the length of the opposite side. I want to find the measure of that angle, but I know the length of its opposite side, so I can set this up real nicely. And what I see is what? Well, sine of the angle, 62 degrees, divided by the length of the side opposite, is equal to the sine of the angle we want, sine of F, the F angle, divided by the length of its opposite side. And so now, the first thing I'll do is find what the sine of F is, and then I'll figure out what F is. How do I do that? Well, you could take the cross product if you want, and then divide both sides by 9, and what you would see is sine of F equals 8 times the sine of 62 degrees divided by 9. Right? You see why that's true? Sure, because I just basically multiply both sides by the 8, and the 8 comes up here, and I just have sine of F equals 8 sine 62 over 9. Great. Now, how do I find out what F is? Well, this is going to be a trigonometric tongue twister, actually, because now I've got to use the inverse sine function. So sine of F equals that. That means that F equals the inverse sine function of that. So F, here's the big finish, equals the inverse sine of 8 sine 62 degrees all over 9. Isn't this the scariest thing you've ever seen? So F is the angle whose sine is 8 times sine 62 over 9. That's what I want. Well, that looks scary, but it shouldn't be. All we've got to do is just carefully type everything into a calculator, and you can estimate it. And if we estimate this to the nearest degree, we see 52 degrees. I won't even bore you with plugging it in, but definitely try it and see if you can actually see that you get 52 degrees. Anyway, the law of sines is an absolutely beautiful result that I really, really love. And the reason is because it allows us to take any triangle at all and make that triangle seem special.